So we're back for another episode of Intro to Electronics.
I see you're wearing the same shirt.
Yeah, you too. We filmed these back to back. Spoiler alert. So in the last episode, we started to dive into motors, right?
Yep.
Servo motors. In this one, we want to jumpstart a little bit. So what do we have set up here?
So we've got a lot of the same parts and pieces that we had in the past. We still have the Arduino R4. Uno R4 with Wi-Fi right here. We've gone ahead and from the plug and make kit utilized their, I don't know what they call it, but it's essentially like a breadboard for modules without, electrical continuity, conductivity. There might be something like that on the back, but we're not there. And the reason we did this was just to kind of clean some things up.
Right.
We still have the servo motor connected as we did, remembering your GVS, ground, voltage, and signal.
Right. So our ground is the black, which we have running to the ground over here.
Yep.
Our signal is running to port number 9, the PWM port over here. And then our power, 5 volt, right there.
Yep. And honestly, we're using the Arduino ecosystem, so to speak, but these ideas all kind of apply to any microcontroller you're going to use, or even the GPIO pins on a Raspberry Pi. So those 40 pins that you have access to, whether they have pins already or you solder directly onto them, these type of ideas still apply. You would still have a ground, a voltage, and then you would also have a signal which tells it what to do or where to go. So we've added a few more things. We're taking advantage of the QWIIC port, quick port, on
Quick. I get it.
Yeah. on the R4, which I believe, and again, here's me showing my ignorance, I believe it's using an I2S protocol. What that means, it's like kind of another serial protocol, but it allows you, this is totally how I understand it. It allows you to daisy chain things together and address them kind of in a line. So what we have going on, and this helps tremendously for organization of cables.
So I see 4 cables coming out of this, right? So if I had to take a crack at it, I'm assuming the black is ground.
Yep.
The yellow is data. The red is power. And then there's another black for something else?
Yes. So if I had to take a crack at it, you're correct. You're correct. And then the 2 yellow and bluish, dark bluish lines.
Oh, it is blue. Okay. Yeah. So there's a blue, a black, a red, and a yellow. Yep, right. You're right.
They are data and clock. So when you're doing daisy chaining, in order to talk to other devices, you kind of need like what we have with like the crystal oscillator on the Uno R3 board. Right. But let's double check that. So 4 wire, what did we call it? I2S, I2C. What they mean? Question mark. If we go to the actual Arduino website, I2C protocol, what is it? It provides, it involves using 2 lines to send and receive data, a serial clock pin, SCL, that the Arduino controller board pulses at a regular interval.
Right.
And then a serial data pin. So yeah, it's data and a clock.
Okay.
And the clock basically is, I don't want to use the wrong words, but parity, or basically allows it to make sure that it's sending data. The data that it's sending has a reference into how fast it's going, ones and zeros.
Right. And so that they're all kind of in sync. That's how it keeps them all in sync, is that clock.
Yep.
That makes sense. Okay.
So here's an example of an I2C message, which, nope, not going to get into today. I2C pins.
There's a lot of binary.
Yeah. Here you go. Here's your bare I2C wiring. So yeah, your voltage is your red, your ground is your black, your data is yellow.
Right, yellow.
And the clock is gray. So they could be mixed up or backwards. I don't know which one they are in this case.
Got it. Okay.
And luckily for us, we don't care, because Arduino has written something called a library, which we've talked about previously, a Modulino library, which makes referencing a lot of these Modulinos very easy.
Okay. So we have that connected to some of these Modulinos here, which we already connected to this board, which you didn't put bolts. They're just, well, they're in place.
Yeah, I didn't put bolts because we can move them around easily.
Right. At least the screws kind of keep them roughly in place, and they're laid out in a nice way too.
Yes.
So walk me through the setup here. What are we going to do with these Modulinos? Obviously, I see the servo right in the middle. What do we have set up here?
So we've got the servo set up and the knob set up. And the other two we have, so servo, knob, daisy chain to the knob. We also have the speaker or the little buzzer, which we're not going to do anything with just yet.
Okay.
And then we have this LED array here. Now these LEDs are not just standard RGB LEDs. Wait, yes they are. Let me try again. These LEDs are not just your standard single color LED, but they are RGB LEDs, which are individually addressable. So if you've messed with this stuff before and you've heard things like neopixels or dot stars, these are in line with that. And I think they may actually be in the neopixel, the WS2811 or whatever all those numbers are for this kind of LED. Meaning we can make each one of these as bright or whatever color we want individually. They don't all have to be red. They don't all have to be green. So our goal with that is as we turn the knob, the LEDs would act kind of like a position meter or a VU meter.
Okay.
So we'll see if we can get that working. And then maybe we'll have the buzzer do like a low tone at 0 and a high tone at 180.
Right. Okay.
So let's dive in and take a look. We've already made some of this code. And we've used AI to generate this code. So let's take a look at it. We're calling out the library for the Modulino.
Modulino.
So there's a mysterious backend file somewhere which explains to the R4 what to do with all the Modulinos. And then we're calling out the servo library again, which we've used in the past. Again, tells us how to deal with the servo.
Right.
So we are inciting the Modulino knob and the Modulino pixels.
Got it.
So far. We still have our servo pin set to 9. And we have the number of pixels set to 10. Does that look right?
I count 8.
That's interesting.
Okay.
We should change it to 8. Serial begin. Remember we talked about the baud last time.
Right.
We'll see if anything happens in the serial monitor with this code. Knob begin, pixels begin. That just means like start listening, start getting ready to receive these commands for the knob and for the pixels and for my servo. Here it says I'm going to clear all the pixels at the beginning, like make them all off.
Right.
So if they started with red before, now there's nothing. And then we get down to the loop, the part that's going to go over and over and over again, hence the name loop. Initial value, get the value of the knob, and then map that value 0 to 1 or 1023 to 0 to 180.
Got it.
So the knob itself can read values 0 to 1023. And really, we might have to look into this because this knob is not just your standard potentiometer. This knob can spin around so many times.
Like freely, right?
Yep, because it is a rotary knob with a button actuator.
Interesting.
So we could use that function as well. Maybe hitting that takes it back to 0.
Right, like a reset.
Yep.
Okay.
And then pixels clear. It looks like we're going to use the color green. And delay 30 milliseconds. So that's really fast. It's constantly polling or doing that.
Okay.
Let's go ahead and send this over and see what happens.
And while we wait, another message from our sponsor, us. Here at Microcenter, you can get all of these electronic components.
And more.
Like electrobits. Electrobits are the future of electronic bits that you can find at Microcenter. Insert pictures here.
Do you need just like a small amount of bits?
That are electrocuted?
Little bits.
Little bits. Can't use that. Little bits. We're
Why
waiting.
not?
We're waiting for it to upload still.
The port is busy.
Electrobits. You can say that.
Console's updating. Oh, there it goes. There goes the TXRX.
Yep, there it is. It's
It's
updated.
RX right now. Okay. Anything? Should we try to actuate it using the
Start
knob?
spinning.
Yeah, go
All
ahead.
right, let's go. I'm turning it.
Oh, it's very fine, but it is in fact turning. You can see that sticker starting to move and point different
Yeah.
places.
Okay. Oh, we got a light. Oh, I've really got to turn this a lot. So,
Yeah, you've got to go for a couple of days here.
so what are we missing here? Why is this taking so many turns?
I think, well, one or two reasons. One, the code's treating the knob as like a potentiometer for some reason, or our mapping is too fine.
Right.
So what I would do is I would say, okay, this all looks good and makes sense and did what we wanted it to do.
Right.
I'll be honest. Well, which way's the camera pointing?
Right there.
Which way's up? Is this up?
This is up.
That's up.
Okay, so for me, what I prefer to see. Now we could do this in code. I prefer to see it roundaboutly, and I think we can do that no problem by just rotating it,
What, just flipping it?
which is kind of wild. And the reason I say that is because usually data in, data out has a direction, but when you're using the I2C, I guess it doesn't matter.
We'll find
Comment
out.
down below why it doesn't matter, if you know. So let's plug it back in, see if it goes the direction we want now. This was kind of like the, not brute force, but the easy way of making it the way we want it, so to
Right.
speak. And actually, let's do this again. Let's get us kind of
That should be 0, right?
zeroed out. Yep.
Okay. So it should still just be running the code, right? Yep.
Yep.
There we go.
There we go. Yep.
All right.
It's starting at the bottom
We got
now.
1, 2. See, so it looks like we're almost at 90. That's 90. Okay.
Yep. Yeah, so that mapping's pretty good. I really encourage everybody, as we're going through these like basic things, try to think of things in the real world which have like some similar attribute, something where you're turning a knob and it's affecting something else somewhere, right? Honestly, imagine this is a steering wheel,
Right.
and this is the part that controls which direction the wheels turn. That used to be all linkages, right? Now it's pretty much
It's all digital.
digital,
Yeah. It's
Yeah.
all signals.
all signals. So if you're making an RC car, you could have a knob. This could be your direction knob, and this could be what controls the direction of the wheels. Now that would be more mechanical, but still all through digital signals. And we're just using the LEDs as a feedback loop.
Right. So how do we fix the fineness of this knob?
How do we adjust how quickly it does what we want it to do?
Yeah, because I actually almost want it to follow me. Like if I have this in this position, I want this as 180. I want this as 0. And I
Okay.
want to, right? How can we get there?
So let's talk to AI. And what we need to know is the right words to communicate. And what I'm going to say is, first and foremost, hey, thanks. That's great. Now I'd like to
Great job.
make it more like a 1-to-1, where when I turn the knob Modulino, I'm going to put in parentheses, tell it that it's a rotary knob, make sure it understands that, which I think it would have to based on the libraries.
Yeah, but still, it's better to be specific when it comes to AI.
Yep. 1-to-1, where when I turn the knob Modulino, which is rotary, it goes from 0 to 180 in a single rotation. Let's see what it says. Awesome. See,
Not a potentiometer. Yes. Knob.get.
so it's going to read whether it's turning right or left.
Clockwise to increase, counterclockwise to decrease. That's what I want.
And it looks like it's done writing it, so let's copy and send that over. And then... Oh no. We have lost connection.
I'm sure you're in the right window.
There it is. I'm not sure, but now we're connected again.
That's all that matters. That connection.
Let's clean some stuff up. Now, in order to write this code and understand it appropriately before my laptop dies, I should probably get a
charger.
power supply.
And while he gets that, another word from our sponsor, Priority Care Plus. If you ever wanted...
All right. So we're back at it. What did we do? Did we send the code? I forget where we left.
His laptop was dying, so we had to plug it in. Send it again. See if it uploaded.
Well, we could just turn it and see.
Good point.
Nope, it did not. Is it doing it? We broke it.
Uh-oh. Now we have to troubleshoot.
Yep. Well, let's see what done uploading. New sketch. All right, so let's go back over to ChatGPT. Yell at it. Please be fixing.
But it did upload?
It said it did, but it went real fast comparatively. So let's try this again. Console verifying.
Verifying.
Let's see if we can figure out... Oh.
Number of pixels should be 8.
Yeah, I thought we told it that. So what's it doing now? So it's saying that the knob, Modulino knob, number 9, initial angle 90. Talk to it, talk to it, talk to it, go. Oh, here's a weird thing.
Delta equals knob, get delta, change in rotary position since last check.
So it's trying to deal with the... So over here on the console, you can hit copy. You can go to here, and you can say, hey, buddy, what's up? What's up? And it's like, oh, the Modulino knob you're using is treated as an analog potentiometer, not a rotary encoder, even if the physical knob rotates indefinitely. Mm-hmm. So it's like, I did it right the first time. You tried to tell me that I didn't, but I did. And so, okay.
Gotta trust the AI, huh?
Some days. All days. All days. We trust you.
Half the time.
Okay, copy. Back to it. What happened? All right. Console verifying. I'm excited for this. I mean, if it works, it works.
Right. And if it doesn't, we can just keep working on it until it does.
That's it. Don't give up. Don't ever give up.
Never give up. Never surrender.
What's that from?
Galaxy Quest. Remember that one? One of the top 5 Star Trek movies ever made. All right, so.
It went.
All right, the code went.
It's all be lit up. It's still pretty coarse.
It's still extremely...
Better or worse?
Seems about the same, to be honest.
All right, so let's go tell it. We got it back to normal working, but let's go ahead and tell it. All right, but it's still way too fine. We need it to rotate much faster. And if we see how it does it in the code, then we can modify it up or down. So input, acceleration. We'll treat the analog like an acceleration input, not a position. That's wild. So depending on how fast you turn it.
We can accelerate.
Yeah.
I see.
It's kind of like on a video game controller. You have your switches up here, but then these ones are actually analog. So depending on how far you push them is how fast you actuate whatever the player's doing. All right, so let's go ahead and take that and try it and see what happens. Let's see if I can see anything in here. Angle plus speed, constraint angle 0 on 180.
LED set to 10 still.
Oh, yeah.
Yeah, see, number of pixels 10. Got to QC check that.
Yep. please remember going forward, there are only 8 LEDs. All right. I don't know what the code actually does. If we tell it 10, like, does it just imagine there's 2 more higher and then it takes longer to reduce or increase?
Or if this is 0, that's 100. Are there 2 imaginaries in between that it's not hitting?
Yep. Okay.
Do you want to upload it with the right one? With the right number?
Console verify. But I mean, while this is uploading, you know, there's these other Modulinos we have, which could do any number of things. So for instance, this is a Modulino movement, which I don't know what the actual, it's LSM6DSOX. So 6 degrees of movement. And basically this could control.
Like a gyro control?
It could control the servo, yeah.
Oh.
So if you want to put this in a glove and then become the controller like a robot hand.
Right. Ooh, and I can do that. And it has 6.
Yep.
Okay, all right.
All right, let's see what happens. And nothing. I think what happened is it tried to convert it back to a rotary knob. This is interesting. It's not that I've never seen something that is something else being used as something else, but the way that the Modulino library is handling this is kind of interesting. Okay, that doesn't work. I think you put the Modulino knob back to rotary again. Look at that. It said I'm exactly right. It mistakenly switched the Modulino knob.
That didn't make a mistake.
You want 1 full rotation of the physical knob to control the servo from 0 quickly and directly, not sluggish. Fine. Final corrected sketch. Fast linear mapping with 8 pixels.
Hey, AI, one lesson I can teach you as someone who's done a lot of creative work and design work, never ever label anything as final, because it's going to be final-2, final-V3, final-V7.
Yep. Final.
Final.
Till it doesn't fit anymore.
AI has a lot to learn.
But it's going to learn so much faster than we never could. Ever. That's right, folks. Get out there and support your local data centers.
We put lightning in rocks, and now they think.
Here it goes.
Okay, so I see it transmitting, receiving.
Yeah, let's see if we can see any differences here.
Number of pixels are correct, 8.
Yep. Yeah, it takes the raw 0 to 123, 0 to use a steeper mapping curve for the rotation field. I don't understand. I don't know what this raw means. Raw equals knob get. Not at all. Final.
Wait. I just pressed it a bunch and now it's finally working. But it's still just as fine as it was before.
Yeah. Use a steeper mapping curve for faster rotation feel. Oh, I mean, you could do, let me see what happens if I do this. If I take 0 to, instead of 0 to 1023, map 0, 180,
to 100.
0 number of pixels.
Divide it into half?
Yeah, 512 or 5.
Do 250, do 255.
That's a quarter.
Yeah, I want to see what happens.
Now we're trying stuff. Console verifying, console uploading, flashing. It'd be funny if it was like mad about this. You can't change that number.
All right, so that's back to 0, back to 0. So let's see what happens.
I wonder if it's a thing where it like takes a while to get started, like you're so far down or so far up. Yeah, just keep going for a minute. Sadness. We need like a little motor. I wonder if anything's coming through on the serial monitor. Try turning it again. And remember, folks, at home, our bauds need to match.
Okay, now it's working.
That's a little bit quicker.
You changed the baud, now it's working.
That shouldn't have been it.
Well, whatever it is you did, it's doing the trick now.
I'm wondering if maybe we have a sad connection somewhere. Is it still working?
Yeah, watch. Because look.
Yeah. So then I guess the question is, could you map it even lower?
So we did 255. Try like 127.
Let's just try 100. Riveting.
Fascinating.
And then we can make it beep. We can make it play the Mario theme anytime you press the button.
Sued.
Yeah, no, don't do that. There it goes. There it goes.
All right, so we found by reducing the angle or reducing the mapping, we're getting better. See, that's what we're looking for.
I mean, I think we got to take it down to like... So rotary knobs have a number of detents or steps.
Right.
So if I go and I say, what's a typical rotary, that might actually... What is the typical number of steps in a rotary knobber? Bum, 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 bum. I'm just going to say 60 steps per click, 24 steps. Let's see what happens at 24. And we're just going to modify the sketch in here. We don't need to tell... Yeah, 24 should be pretty quick. Now, is this the right way to do it by modifying this? I think so. I mean, it's working. That's a lot of what Arduino is. You change little bits here and there, single things at a time. You mess with it, see what your outcome is.
Mm-hmm.
Now we'll go to 0. It does. Okay. It's like you got to get to a certain point where it gets started. Yeah, there's a like a starting point.
Now we're cooking.
That's what you were looking for. Only took us 2 hours.
So full 180, 90-ish. I think the horn is like slightly askew. So yeah, if I over rotate, I have to do all of that back. See, and then there it is.
Right, because it's...
And if I under rotate, I have to go all the way back, like to reset.
Right.
So we have to figure out how to get it to just sort of cap out, I guess.
Well, it's kind of like you want it to be not absolute but relative.
Mm-hmm.
So that would be the servo control web server. Okay, but can you make it relative so that the knob doesn't have dead space at the top or bottom of its range?
This is just entertaining.
It is. Yeah, what could you do with that? What does it look like? What does it remind you of? I don't have an example this time, so
Here,
that's all
listen.
you. DJ Jazzy Jordan.
Do, 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 do. Do, 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 do.
Why?
It's the melody in a funky town. So in theory, what we could do with something like this kind of setup, is we can have this, how we were using this to pull something before, in a very rudimentary fashion. But we can use this to sort of like pull or move something, because you can put something mechanical on it,
Right.
to have it like sort of...
Oh, it's still right.
So something like this is kind of what I'm talking about, because we could put this sort of on a slider,
Yep.
attach this to a camera on a slider, and I can sort of like move it back and forth between
Yep.
these two full movements.
Yep. Or you could program it. You could have, like using this Modulino here, you could have 3 different pre-defined spots. Go to,
A, B, C,
right.
and it would just move it to those positions.
Yep. And then ideally, you could also have it on here, if we can get the text to right, you could have it say position 1, position 2.
Right.
So, I don't know. Do we want to do any more here today, or is that pretty good?
I guess that's a pretty good stopping point for now. I think we just wanted to show a quick demonstration of Modulinos, a quick demonstration of sort of getting some of them to work together. I know we didn't do the sound one yet, but maybe we can build
Right.
off of this.
Yep. There's, again, inputs and outputs. Your input is, in this case, the knob. Your outputs, even though they're on the same chain, are going to be your LEDs, your little buzzer, and the servo. So the outputs could also be these LEDs matrix here.
Do you want to see if you can do a quick one for the thing?
The buzzer?
Yeah,
All right.
just ask it. Just say, hey, there's a buzzer on this. Can you make it low pitched at 0, high pitched at 100?
Yep.
And just see what it does.
Right. Yeah, let's do it.
And then we can get lunch. Lunch time.
Asdiv.
Do you still have free cheesesteaks every week?
No,
You were living the life.
that was the
You
life
had it made.
with lemonade.
Circle, circle, dot, dot.
Now I'm having cootie shot. Okay, so we asked it to make the knob relative space, no dead space at the top or bottom, and then play the Funky Town melody on the buzzer when the servo hits the top value of the LED. Combined working sketch.
Uh-huh.
This is going to be fun. What you'll see in this sketch is how it starts to handle like melodies. That's a whole other thing.
Right.
And there's a function called play Funky Town. And if you look at it, 659, let's say that's bum. So you'd have bum, 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 bum. That goes higher. That's weird.
Bum, bum, bum. Bum, 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 bum.
Bum, bum,
Bum.
bum, 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 bum.
That doesn't seem right.
It's a melody.
Yeah.
Let's go with it.
Let's see. Oh, maybe that's like a non-copyright infringing version.
Right. They knew what we were up to. So, which they always know. Let's see. Are we going to hit this one out of the park? Hard to say. Simplified Funky Town intro.
Yeah,
Like,
see, that's why it's simplified.
Comment. Thank you, ChatGPT. The other thing that I've asked ChatGPT to do in the past is put a date created. I think I'm going to ask it to add a timestamp too. That way I can always see like...
Keep track of the progression.
Yep. Did it do it? Really? That was too quick. Let me try again. Something tells me, okay, there's buzzer. It's also possible the buzzer, I think the buzzer is capable of doing melody, but maybe not. It should be.
Humor me. Open up the serial monitor. For some reason, when you opened it before, it like magically did stuff.
Change the bauds. Let's try this. Reset. It should theoretically...
If you turn the thing physically.
no, it's locked. Let's try.
Unplug it
reset.
and plug it again.
The LED should go blank, so something changed where the LEDs aren't going blank. Because it should know where the servo motor is currently. 3 hours later.
So we got this working. We got it spinning. We got it to respond to the knob. So I think from here, we could just take this and maybe we could just kind of keep adding to it and just see what some of the different Modulinos do. Maybe we'll try like this guy,
Yeah.
the little clicker, so we can try maybe one with the knob, one with the clicks, and then we'll get the audio one working as well.
Yeah, and there's kind of a really cool one, which I think we can get working without too much trouble. But remember, this one has Wi-Fi built in. Mm-hmm. And one of the things you can do with a Wi-Fi enabled microcontroller is serve up its own web page. So this can act as an access point to which we can connect and view like a simplified web page. So imagine having a slider on your phone
And then you can
that
connect
then
to it.
turns this. Yes. So
Interesting.
that's more than possible.
Okay, so we'll do this piecemeal, but we're going to start doing some real fun things now. I can already see the potential here, and then maybe we can start implementing some 3D prints too to sort of get things together.
Yes.
Right?
Yes.
Yeah, that's when it's really going to take off.
We're going to call Jacob.
Yeah, he's going to help us with that. Cool. All right, well, this has been fun. We'll catch you guys in the next one.
See ya.